What's up, everybody? It's Mr. Harris. We're going to talk about 8.5, which is all about variations. And the first type of variation we have is direct variation. And this should look familiar because we did this in the beginning of the year. It is when y is equal to a times x, and a is a constant. So for number 1, we're given x equals 5, y equals 10. So we got to find an equation then we have to find y when x is equal to 4. So our first step is we got to find a. So we have y equals ax, so I'm going to plug these two numbers in. 10 equals a times 5, so 10 is equal to 5a. Well, if I divide both sides by 5, I get 2 is equal to a. So my equation is y equals 2x. So that's part of it. That's the first thing we did. We also need to find y when x is equal to 4. So y equals 2 times 4. So y is equal to 8. That's all there is for direct variation. Now our second type of thing is called inverse variation. Inverse variation is y equals a times x, and x is not allowed to be 0. Just like kind of what we talked about, if we have 0 on the denominator, that's a no-go. We cannot let that happen. So for example number 2, I have x and y vary inversely. X is equal to 4, y is equal to 7. Same thing like last time, we got to find the equation. And then find y when x is equal to negative 2. So finding a, because a is our constant, we have y equals a over x, so we have 7 equals a over 4. And to get a by itself, we're going to multiply both sides by 4, so those cancel out. 28 is equal to a. So the equation that I have is y equals a over x, so 28 over x. This is my equation, my general equation for inverse variation for this problem. Now we also have to find y when x equals 2, so I'm just going to plug negative 2 into this equation. Y equals 28 over negative 2, and I get y is equal to negative 14. And our third and final type of variation is called joint variation. And joint variation is just a product of two or more quantities. So that means, like right here, we have a times x. We're actually going to have another variable. We're going to add in z. Z equals a times x times y. So see how my constant a is multiplying x and y? A is always our constant no matter what. So for number 3, it's going to tell you that x, y, and z are vary jointly. So I'm going to say that z equals negative 75, x equals 3, y equals negative 5. We got to find the equation. Then find y. Sorry, not y, but z when x is equal to 2 and y is equal to 6. So first I'm going to find a, which is my constant, given these three values. So I have negative 75 equals a times 3 times negative 5. Negative 75 equals negative 15a. Divide both sides by negative 15. And I get a is equal to 5. So for my equation, I have z equals 5xy. I'm just plugging a into my formula to get our general equation. So now it's saying, hey, we got to find z when x is 2, y is 6. So z equals 5 times 2 times 6, and z is 60. So always look first and see what the problem is asking you. Always find A, but see, hey, is it saying, is it varying directly, is it varying inversely, or is it varying jointly? And you have to pick which one you'll be using. Again, we're not allowed to have 0 on the denominator. If there's two things that are true, is that 0 can't be on the denominator, and Carol Baskins definitely killed her husband.